friend from Meta comes up here. Mr. Kirkland, are you in the audience? Oh, you're on that side. The two things I will say before I introduce him is, please fill out the surveys. They really are important. And fill out the surveys. Now, please join me in welcoming Matthew Kirkland, who actually I've talked to you before about V6, at IETF even, I think. I'd like to introduce Matthew Kirkland, who will be presenting Removing IPv4 Infrastructure Addressing from Meta's Edge Network. Matthew is a network automation engineer at Meta and traveled from Denver to join us today. This is his first time presenting at NANOG, and it's a pleasure to have him speaking with us today. Welcome, Matthew. Can we have a big round of applause for him when he comes up?
Thank you. Well, for the introduction, but I'm Matt Kirkland, network engineer at Meta. Today I'm going to be talking about our experience in removing IPv4 addressing from Meta's edge network infrastructure. Okay, so going through like why we want to do this. So at Meta, we operate four main network areas. Firstly, the data center networks, which are within the data halls. We have a core network that connects all of the data centers together, and an edge network, which consists of the peering points of presence and the network that connects them to the data centers. There is also an out-of-band network across those. Okay, so actually lining up with what Jeff said, we see that our IPv6 adoption for our user traffic is sitting about 40%, where our internal traffic is more than 99% IPv6. So is a simplified diagram of the edge network. Starting from the bottom going up, we've got the server to top of rack. That is already IPv6 only. And we have the top of rack to rack aggregation layer through to a metro aggregation layer, which connects many rack aggregations, and then to our peering and backbone layers. All of the connections between these layers are fully meshed and dual stack. So why do anything else? Why not just keep operating with our dual stack infrastructure? Well, for one, simplification. So we're running two address families for BGP across all of the network devices. There's a lot of state and a lot of configuration. We also have, as in the previous diagram, all of the circuits in the full mesh need to have v4 point-to-point addresses. In the larger POPs, this makes for assignment of many addresses. And as we grow the network, IPv4 space, being as limited as it is, becomes a planning headache. Okay, so going through how we went about it. So this is the timeline we started with last year, where we started with the metro aggregation layer because that was the area of the network, of the edge network, seeing the most growth. So from that to the rack aggregation layer, we removed the v4 addressing. And then once that was complete, we moved on to the rack aggregation to top of rack switch. The last thing to do in each of these was to remove the actual addresses from our database, just in case we needed to roll back. Don't think I need to explain to anyone really about what dual stack is, but I will. So looking at the diagram here between two routers, we have one link which is addressed with a v4 address and a v6 address. We then have two separate BGP sessions, one operating over v4 and one operating over v6, carrying their respective address family prefixes. What we move to is RFC 5549 or 8950, which I'll just refer to as 5549 because that's what I've done for 2 years, where we only have a v6 address on the link. That link, then we have a IPv6 BGP session, which carries v6 and v4 prefix updates with a v6 next hop. So, what all we need to do, remove the v4 addressing, change BGP, and that's it, right? Sounds easy. Unfortunately, it was not. So starting, our first challenge was traceroute. So a lot of our network users internally like using traceroute as a diagnostic tool, but in the absence of v4 link addresses, what information can you get when that turns out that that is only the loopback address of the router that's being transited? So there are two RFCs to help address this lack of loss of detail. One is RFC 8335, which is a utility for probing interfaces. Another is RFC 5837, extending RCMP for interface and next hop identification. So we worked with our vendors to try and get these implemented in code. At the time of writing these slides, it was not there. So tooling, our own internal tooling, so this is one on us, may come as a shock to many, but coders writing tools like shortcuts. So, for example, we have a service that monitors paths between servers and network paths, and this was only ever implemented with v6. In a dual stack scenario, that doesn't matter as much because they share the same fate. But in the case of v4 being removed, we lost visibility on v4. We also have a lot of health checks and audits in place in the network, and when written, they assumed that we had v4 BGP sessions as well as v6. Lastly, our provisioning tools, which create all of the circuits between our layers, automatically assign v4 and v6. So those needed to change. BGP policy. So when you only have one BGP session, your BGP policy might need to change. Some vendors allow you to have a distinct policy per address family on the same BGP session. Others will only allow you to have one, in which case you need to update your policies to account for v4 prefix lists and v6 prefix lists in the same policy. So one of the very first challenges we had in doing the migration was ECMP. Our first vendor would, when you had routes that were mixed address family next hop, so v4 next hop as well as v6 next hop, all other BGP attributes being equal, they would only install the v6 next hop. Which meant that the minute you turned v6 only session between two routers, that link would attract all of the traffic. So we need to implement policy to try and share the load across the fabric. Interestingly, a different vendor did what you would expect and would have different address family next hops in the same ECMP group. And our third vendor would prefer v4 over v6. So 3 vendors and 3 different approaches. Once you have the actual BGP signaling working, that doesn't mean you're finished. So it turns out that each vendor's device needs to have a configuration to allow you to forward v4 packets across a v6 only interface. Some of the vendors, this is a global command, some of it's interface command, and a third is just inferred by the address families active on the interface, not necessarily addressed. Excuse me. So even within the same vendor, the requirement for this command was not consistently applied. So some platforms worked just without it, and some did not. One of the important things to do when you are doing these migrations is having a view of distinct address family traffic. So we wanted to have distinct v6, v4 counters on our interfaces. One vendor, you get this for free. It just is enabled. Another vendor, you have to enable it. And then within their platforms, some platforms would give you ingress and egress counts, some only egress. And a third vendor, you could enable v6 counters, not v4, so it's up to you to work out the delta between the total and v6 counters. Okay, so once we've done the metro aggregation up to the top rack server, the last piece is the peering layer. So in the peering layer, we operate an ISIS level 1 domain with segment routing. So it's a single topology ISIS, which it turns out does not consistently support v6 only across vendors. So one vendor, you remove the v4 address on the interface, only v6, and single topology ISIS works. Different vendor, you are forced to move to multi-topology ISIS to get v6 only. Which means that you have to move to multi-topology to get the support across that layer, which makes migration pretty painful. So I mentioned that there was segment routing in there. And so the label forwarding with the segment routing on ISIS worked as we expected. So a labeled packet comes in, a packet comes in, the label is applied, forwarded to the LER. LER then pops that on the penultimate hop and forwards it out of the interface to the last hop. It turns out we were just lucky because the LSR in this diagram was a different vendor to the LERs. If we had used the same vendor as the LER across all three nodes, we would not be able to forward traffic because the v4 packet, once it was decapsulated at the penultimate hop, a check would be made against the address family in the packet header and the link address, and you would drop the packet. This is a separate check to the one that we disabled with a command earlier, and it cannot be turned off. Okay, so once we work our way through that, what do we want to do next? What's in the future? We would like to use v6 only across our core, and in this case, core meaning the POP to data center network. And this network runs RS3PTE, and there is no support for v6 signaling on RS3P, despite it being in the RFC published in 2001. We went to 4 vendors asking about v6 RS3P, and more than one told us that no one had ever asked for this before, which I find interesting. On the positive side, can we just enable BGP to be v6 only? And yes, we can. So we could turn on 5549 between all of the LERs and just exchange v4 routing prefixes across that. There is caveats with one of my vendors telling me that you can do that, but if you need to use explicit null, a v6 explicit null label will be applied and your v4 packet will be dropped at the tail end. So, more testing needed. Okay. So in summary, 5549 BGP signaling of v4 prefixes with v6 next hop works. the issues are mainly seem to be around forwarding, that there's not been this connection between routing and actually forwarding, where there's a bit of work to be done. So a lot of testing is needed in order to make this work in your specific network case. And lastly, I think this has definitely been worthwhile. We've saved a lot of IP address space across the network, and simplified our configuration by only having one address family to configure. That was my presentation. Any questions?
Oh my, thank you very much. Who do we have coming up to the microphone first?
Well,
I think me.
That side, please.
Murray Google, and I happen to be IETF Ops AD. So this is clearly supposed to just work, right? Like when routing happens, you figure out what the next hop is. It doesn't actually matter if it's a v4 or a v6 thing. You eventually resolve it something and ship it out.
sure.
So myself and a couple of others are actually writing a document explaining that this is supposed to just work. And you had a couple of things like traceroute doesn't work properly at the moment.
Yeah.
Bill Fenner has a document which is supposed to fix that, where instead of returning the IP address of the box, you return the host ID, so like a host name or something. So there is a bunch of work underway to try and make this better, but there are a bunch of implementation things which clearly aren't working right. And it would be really helpful if we had like a list of those, if you have those written up somewhere, or if you'd be willing to provide feedback on the draft or something, because like it should just work.
As I say, the signaling seems to work fine, even interoperability, but forwarding does not. Like there's a lot of behaviors in forwarding that have not been thought of by the looks of things.
A lot of it also just seems to be weird CLI stuff. Like I should be able to set a v6 next hop for a static route, a v4 static route, but like most or many implementations won't let you do that because the CLI parser is just like makes no sense and barfs. So feedback great.
Thank you.
Lee, before you come on, anything from the outside? Oh, who's my person? Oh, Mike, you're my person. No, okay. Sorry, Lee, go ahead.
Lee Howard, IPv4.global by Hilco Streambank. Actually, when Warren came up and said, was asking that exact question, I almost wanted to invite you as a former V6 Ops working group chair to come in and present to V6 Ops at IETF. Not my authority. I'm very interested, though, in the goals that you stated, motivations, included address conservation, because that's running out. And you did say, wow, you reclaimed a lot of IPv4 addresses. And I'm wondering, sort of back to Jeff's up and to the right kind of curves, does it look to you like the growth rate of Meta's platforms is in line with the projections for the growth rate of IPv6? Are you going to be running out of IPv4? Are you going to? Is it getting to a point where you're going to be okay?
I mean, we've acquired some IPv4 space more recently, so on that front, we're not about to run out. But we were consuming a /21 every 3 months on just link addresses, so we needed to stop doing that. Really.
Thank you. I'm also, if you don't mind, I'm curious about because I'd seen some old reports about the performance of IPv6 versus IPv4. Jeff also has some interesting metrics on that, and Facebook included. I'd seen some reports from back in the day, 10, 15 years ago, about the relative performance of v6 over v4 and v6 having a slightly lower latency in many cases. I realized this was not an edge network conversation, but are you still seeing that kind of performance difference?
I have not looked into that, to be honest. We're still carrying the v4 packets. They're just being carried with a v6 next hop.
Right. Okay. Thanks.
Hello, I'm River from RBC, and my question is a bit naive, but considering you had to do all of this work around to make it work, in the end, do you feel it was not actually harder to do all of this than keep the dual stack networks in terms of complexity?
I mean, it definitely was harder than we thought it was going to be going in, with a lot of gotchas that cropped up. That some of them were detailed here, but I still think it's worthwhile doing from our perspective, because there's no reason for us to be using those addresses as we were, when we can use them for, say, CDN numbering for people.
Thank you.
Anton Capella, 5.9s. Excellent prezzo. Love seeing V6 happening. Sorry for the feedback. So the question here is, referring back to a presentation panel we were giving yesterday, several colleagues and I were talking about edge network stuff and how we found certain efficiencies in what we do to things that, air quotes, plug in and touch users. And much of that centers around, sort of broadband network gateway concepts that all generally borrow notions of unnumbered interface abstractions and so forth. Just to pick on Cisco a little bit, many of the protocols you're mentioning here explicitly don't work and have never had written RFC-backed support mechanisms to do things like this on such unnumbered constructs. So for example, OSPF doesn't know what the interface is if it's got no address assigned to it and so forth. ISIS, just like that and so forth. Some things will work. IGMP and PIM will work, for example, on unnumbered interfaces. They shouldn't, but they do. And so on. And so it makes me wonder, if we're thinking about along the lines of what you're proposing or what you've done so far, if it's new effort nonetheless in any direction, is there any interest in what you've seen here to go in a space that would perhaps push those concepts a bit further forward? I.e., is there something on your mind that might look like an unnumbered v4 compatibility layer of some sort in general across these sorts of things? Is that something that's
well, I mean, if you're talking about having unnumbered interfaces in general, we discussed that briefly with some of our vendors regards to the core network and RSVP. And while you could get it to work, you couldn't get a path. You couldn't get path information.
Sure.
Which is defeating the object.
And so, pursuant to that, second question here is, what do you think long term? Do we think V4 still has to be right in the layer 2, right in the labels? Could it be tunneled in V6? What do you think about this long term?
I feel like we could have no V4 addressed within our infrastructure, and we have to still support it for our users, obviously.
Sure.
So having that as a service on top of V6 routing is what we're aiming for.
Okay, thank you.
No worries.
Mr. Voidy, anything from the outside? The accused stands mute. Matthew, thank you very much.
Thank you.
It was a good first presentation. Please come back.
Thank you.